Hello viewers, welcome to the lecture series of SSC Quantitative Aptitude. This is your tutor Keshav Agarwal and this is lecture on LCM and HCF. So this lecture is going to be based on solving problems. So in this class, we are going to solve problems on LCM and HCF. Question number 1. Let n be the greatest number that will divide 1305, 4665 and 690, leaving the same remainder in each case. Then the sum of digits n is. Let us have a look over the solution. So let us see, n is dividing 1305, then p is the quotient and r is the remainder. When n is dividing 4665, then q is the quotient and r is the remainder. When n is dividing 6905, then s is the quotient and r is the remainder. Like this, we have three equations, and when we subtract 2 and 1, we get 4665 minus 1305 equal to n of q minus p, which when simplified, you will get n times q minus p is equal to 3360. So this is your equation number 4. Now subtract 3 and 2 to obtain equation number 5 and you will get 2240 equal to n times of s minus q. So this is your equation number 5. So HCF of 3360 and 2240 is equal to n. That means 3360 is equal to 1120 into 3 and 2240 equal to 1120 into 2. Therefore, the HCF is 1120. That means n is 1120. So the sum of digits of n is equal to 1 plus 1 plus 2 equal to 4. That is first option. Now, moving on to problem number 2. Which greatest number will divide 3026 and 5053, leaving the remainders 11 and 13 respectively? So 3026 minus 11 equal to 3015 and 5053 minus 13 equal to 5040. So the HCF of this number and this number, take the difference between numbers. The HCF may be difference itself or maybe factor of this difference. So the HCF is 45. So the correct option here is option number 4. Problem number 3. The LCM of two prime numbers x and y, x greater than y is 161. The value of 3y minus x is. The LCM of prime number x and y is 161, which is given to us. So xy equal to 161 and xy is equal to 23 into 7. That means x is equal to 23 and y equal to 7 because it says x is greater than y. So the value of 3y minus x is equal to 3 into 7 minus 23. That means the difference is minus 2. So the correct answer here will be option number A. A and B are two prime numbers such that A greater than B and their LCM is 209. So find the value of A square minus B. So let us suppose A and B be the two prime numbers and it says their LCM is 209. That means since they are prime, so AB is equal to 209. So we can write 209 equal to 11 into 19, and it is also given that A is greater than B, therefore A will be 19 and B will be 11. So now you know the value of A and you know the value of B. So you can substitute in a square minus b, which will give you 350. So the correct option here is option number A. Moving on to problem number 5. The HCF of two numbers is 8. Which one of the following can never be their LCM? So now we are provided with HCF equal to 8, and now LCM should have a factor 8. So check all the options. We have only 60 which does not have factor 8. So it will never be the LCM. So the correct answer here will be option number D. Moving on to problem number 6. HCF and LCM of two numbers are 7 and 140 respectively. If the numbers are between 20 and 45, the sum of numbers is. So HCF of numbers given to us is 7, and let us suppose the numbers are 7x and 7y, and we assume this because HCF is 7, that means 7 divide the numbers that we are talking about. So that means the number should be of the form 7x and 7y. Numbers are between 20 and 45. This information is also given to us. So the required number will be 28 and 35. So the sum of numbers are 28 plus 35, that is equal to 63. So the correct option here will be option number C. Moving to problem number 7. The HCF of two numbers is 23, and the other two factors of their LCM are 13 and 14. The larger of two numbers is. So HCF is given to be 23. That means numbers will be of the form 23x and 23y. And so the LCM will be equal to 23 into xy. Now given that the factors of LCM are 13 and 14, that means LCM is equal to 23 times of 13 times of 14. So numbers be 23 into 13 equal to 299 and 23 into 14 equal to 322. So the larger number is 322. Therefore, the correct option here is option number D. Now, let us move to problem number 8. The LCM of two numbers is 45 times of their HCF. 44 times of their HCF. The sum of the LCM and HCF is 1125. If the number is 25, one number is 25, then the other number is. So we have to find the other number, and one of them is already given to us. So let us suppose the HCF is equal to x. That means LCM is equal to 44x, because it is given that LCM of two numbers is 44 times of their HCF. So this information is obtained from this equation is obtained from the question only. And it is also given that sum of LCM and HCF is 1125. That means HCF plus LCM is equal to 44x plus x, that is equal to 45x. So when you simplify this, you will get 45x equal to 1125 and x is equal to 25. So the HCF is equal to 25 and LCM equal to 25 into 44. So the given one of the number is 25. So the another number y will be the product of. So another number is supposed to be y. The product of numbers is equal to LCM and HCF. So 25 into y is equal to 25 into 25 into 44. That gives y equal to 1100. So the correct option here will be option number A. Now moving on to problem number 9. The sum of two numbers is 36 and their HCF and LCM are 3 and 105 respectively. The sum of the reciprocals of two numbers is. So HCF is given to be 3 and else let us suppose the numbers to be 3x and 3y respectively. So LCM is equal to 3xy, which is equal to 105, and this information is already given to us. That means xy is equal to 35. It is also given that the sum of two numbers is 36. That means 3x plus 3y is equal to 36. If you take the 3 common and send it to the right hand side, you will get x plus y equal to 12. So hence, we require the sum of reciprocal of numbers is equal to 1 upon 3x plus 1 upon 3y, that is equal to x plus y upon 3xy. This implies that 12 upon 3 into 35 is equal to 4 upon 35. So the correct option here will be option number C. Let us now move to problem number 10. The LCM of two numbers is 4 times their HCF. The sum of LCM and HCF is 125. If one of the number is 100, then the other number is. Let HCF is equal to x and LCM equal to 4x. So this information is already given. This relation with HCF is given. So given that HCF plus LCM is equal to 125. So x plus 4x is equal to 125. That means 5x is going to be 125. That means x is 25. So HCF is 25 and LCM is 4 into 25. That means 100. Let another number be y. So product of number is equal to LCM into HCF. So 100 into y is equal to 25 into 100. That means y is equal to 25. So the correct option here is option number B. The LCM of three different numbers is 120. Which of the following cannot be their HCF? So we have four options here and we have to identify which of these is not the HCF of three numbers whose LCM is 120. So in this question, it is given that LCM equal to 120. And we know that LCM is the product of one common factor and the other different factors of the given number. So factorize 120. So we will get 2 into 2 into 3 into 5 into 2. And that means 4 into 3 into 5 into 2. And 4 is the common factor. So common factor is the HCF of the given number. Therefore, HCF is 4. So for the given numbers, the HCF should be multiple of 4. Hence, go through options which is not multiple of 4 and you will get your answer and your answer will be 35. So the correct option here is option number D. Let us move to problem number 12. If A and B are HCF and LCM respectively of two algebraic expressions x and y, and a plus b is equal to x plus y, then obtain the value of a cube plus b cube. So in this question, it is already given that HCF is equal to a and LCM is equal to b. Given numbers are x and y respectively, so the product of numbers is equal to LCM times of HCF. Correct? That means xy equal to AB. And it is also given that a plus b is equal to x plus y. So taking cube both side, you will get a plus b whole cube equal to x plus y whole cube, and expand the cube, a cube plus b cube plus 3ab times of a plus b equal to is x cube plus y cube plus 3xy times of x plus y. And when you simplify this, and some of the stuff will get cancelled because a plus b is known to you, ab is also known to you, ab is equal to xy, a plus b is equal to x plus y. So this thing will get cancelled. So you will get a cube plus b cube equal to x cube plus y cube. So the correct option here will be option number D. Let us now move to next question, that is problem number 13. The LCM of two numbers x and y is 240 times the HCF. So again a relation between LCM and HCF is given to us. If their HCF is 12 and the difference between numbers is 60, then find x plus y. So here the HCF is given to us, that is 12, and it says LCM of two numbers is 204 times of HCF. That means LCM is equal to 204 into 12. So LCM will be 204 equal to 51 into 4. That means 17 into 3 into 4, 17 into 12. So x is going to be 17 into 12 and y is going to be 12 into 12. So x plus y is equal to 12 times of 17 plus 12 and it will be 348. The correct option here is option number C. Moving to question number 14. Three numbers which are co-primes to one another are such that product of first two is 551 and that of last two is 1073. The sum of three numbers is. So let us suppose the numbers be P, Q, R, where P, Q, R, P, Q and R are co-prime numbers. So HCF of co-prime numbers is 1. So therefore HCF PQR is equal to 1. So it says the product of first two is 551 and last two is 1073. So that means PQ is equal to 551, QR equal to 1073. So PQ upon QR is going to be 37 into 29 upon 19 into 29. Q and Q get cancelled. You will get P upon R equal to 37 upon 19. But we need the sum of three numbers. So the common factor here is Q equal to 29 and it gets cancelled. So it will be 37, Q equal to 29 and R equal to 19. The sum of factors is 85. So the correct option here is 85, that is option number C. If P equal to 2 cube into 3 into 3 to the power 10 into 5 and Q equal to 2 to the power 5 into 3 into 7, then the HCF of P and Q is. So here P is provided and Q is provided. So highest common factor of PQ is equal to common factors of P and Q. That means 2 cube into 3. So the correct option here will be option number B. Now problem number 16. Find the HCF of 2 upon 3, 4 upon 5 and 6 upon 7. We have already seen a direct formula to compute HCF of numbers which are in fraction. So it is equal to HCF of numerator upon LCM of denominator. So HCF of 246 is equal to 2 and LCM of 357 is equal to 105. Therefore, the HCF of fraction is equal to 2 upon 105, which is option number B. Let us see question number 17. Three numbers are in ratio 1 is to 2 is to 3 and their HCF is 12. The numbers are. Let the numbers are x, 2x and 3x. Their HCF, that is common factor, is equal to x equal to 12. Therefore, the numbers are x equal to 12, 2x equal to 24, 3x equal to 36. So the correct option here is option number A. Now, problem number 18. Three numbers are in ratio of 1 upon 2 is to 2 upon 3 is to 3 upon 4. If the difference between the greatest number and the smallest number is 33, then the HCF of three numbers is. So let numbers are x upon 2, 2x upon 3 and 3x upon 4. Multiply by 12, LCM of denominator of all the numbers. To all the numbers, we get 6x, 8x and 9x. According to the question, 9x minus 6x is given to be 33 and 3x is equal to 33. So x is equal to 11. Hence the numbers are 66, 88 and 99. And now the HCF of these three numbers are 11. That means correct option here will be option number C. So now let us move to question number 19. The sum and the difference between LCM and HCF of two numbers are 512 and 596. Okay, so if one number is 72, then find the second number. So the sum of LCM and HCF given to me is 512 and LCM minus HCF is 496. That is also given to us. Adding both the equations, twice of LCM is equal to 1008. That means LCM is equal to 504. And now you can substitute the LCM in the equation number 1 to obtain the value of HCF, that is 8. So the first number is 72. And the product of numbers is equal to LCM into HCF. And the product of numbers will be 72 into X. And LCM is known to you and HCF is also known. So you will get X equal to 56. So the correct answer here is option number A. Now let us move to problem number 20. Three electronic devices make a beep after 48 seconds, 72 seconds and 108 seconds respectively. They beeped together at 10 a.m. The time when they will next make a beep together at the earliest is. So LCM of 48, 72 and 108 is equal to 432 seconds. That means 7 minutes 22 seconds. They beep together at 10 a.m. So they beep together at 10 a.m. plus 7 minutes 12 seconds. That is 10, 7, 12 hours. That is A. So what is the least number of soldiers that can be drawn up in troops of 10, 12, 15, 18 and 20 soldiers and also in a form of solid square? So LCM of 10, 12, 15, 18, 20 is equal to 180. The perfect square multiple of 180 is equal to 900. So the correct option here is option number C. The least perfect square which is divisible by each of 21, 36 and 66. So LCM of 21, 36 and 66 equal to 2 into 2 into 3 into 3 into 7 into 11. For making the perfect square, we should multiply by 7 and 11. Hence, the required result is 213,444. So the correct option here will be option number C. The largest 4-digit number which is divisible by each of 12, 15, 18 and 27. So LCM of 12, 15 and 18, 27 is equal to 540. So the largest 4-digit number is 999. Okay. So dividing 999 by 540, we get the remainder 279. That means if I take the difference 999 minus 279, I will get 9720. And if I divide this number by 540, I'll get the remainder 0 this time. So that means 9720 is the largest 4-digit number which is divisible by each of these numbers. So the correct option here is option number B. Now, moving to question number 24. If x is to y be the ratio of two whole numbers and z be their HCF, then the LCM of those two numbers. So ratio of numbers x is to y, HCF equal to z, therefore LCM equal to HCF times other factors. So this is equal to x, y, z. Hence option D is correct. Now, this is the last problem for this lecture. Let x be the smallest number, which when added to 2000 makes the resulting number divisible by 12, 16, 18 and 21. The sum of digits of x is. So LCM of 12, 16, 18, 21 is equal to 1008. And the next number would be multiple of 1008, that is 21016, 3024, etc. But nearest to 2000 is 2016. Therefore, the smallest number which would be added to 2000 is 16. That means x is equal to 16. And we require the sum of digits of x. So it will be 1 plus 6, that is 7. So the correct answer here would be option number C, that is 7. So that would be all for this lecture, and I'll recommend you to solve and try these questions by your own, and I'll see you in the next lecture with more questions on LCM and HCF.